So we're going to continue talking about solving triangles with lesson 12.2. Remember the last lesson we talked about using trig ratios and Pythagorean theorem, but remember those only work on right triangles. So if we have a triangle that is not right, the vocabulary word for that is oblique, so not right triangle, that would be oblique. So when you see the word oblique, make sure you know what that means. We instead have to use some other formulas. These formulas are the law of sines and the law of cosines. You'll notice sines and cosines are those trig functions that you've learned. And in this lesson, we're going to talk about law of sines, and for a little bit later on, we're going to do law of cosines, so not quite yet. So for the law of sines, let's talk about that first. So the law of sines is as follows. The law of sines says the ratio of the sine of an angle to the length of the side opposite is constant in any triangle. So break that down, the angle and then the side opposite that angle. So if you think back to our triangles, when I draw a triangle and when I label them, the opposite side and angle, so the side and angle that are opposite each other, always use the same letter, but remember, angles are capital letters and lowercase letters are sides. Okay, so sine A means the sine of angle A. Lowercase a means the side length that is opposite that angle, side A. Okay, so I can write that ratio, if you think back to ratios, I can write that ratio either way. Sine of the angle on top, side on the bottom, or like I have over here on the right, I can put my sides on top and I can put my angles on the bottom. Okay, and if I set up that ratio between each of my sides and angles, then it's constant for each of those pairs. So for each pair, sine of an angle and opposite side, we have a constant ratio. Okay, so what that tells us is when I have a pair, I can use that pair against another pair where maybe I have an unknown and I can solve that what I know. So for any triangle ABC where my sides are A, B, and C, opposite my angles A, B, and C respectively, then if I have angle side angle or angle angle side, the law of sines can be used because I will have an angle and the side opposite that angle, because I will then have one of my ratios. So I'll either have my ratio side A, angle A, or side B, angle B, or side C, angle C. One of those three pairs I will have to have. Okay, so let's look at what that looks like as an example. So that's a lot of words and sometimes that's hard to follow, so let's look at an actual picture of it. So remember that when I'm solving a triangle, I'm finding the lengths of the sides and the degrees of the angles. So first I want to look at what I have. So I'm given, in this case, two angles and a side, angle side angle, angle A, angle B, and side C. So if I label those, angle A is 42 degrees, angle B is 61 degrees, and side C is 65. Now you might be looking at the picture and thinking, where's your pair? I don't have a pair. I don't have A and A, or B and B, or C and C. I only have A, B, and C. I only have one of each. But remember, in every triangle, if I have two angles, I can find the third. So all I have to do is take 180 minus 61 minus 42, and that's going to give me angle C. So if I do that real quick, we get 77 degrees. That's angle C. So angle C is 77 degrees. I still need to find side B and side A. It's not a right triangle. I can't use Pythagorean theorem. I can't use my sines or cosines or tangents, but I can use the law of sines because now I have a pair. I have this pair right here, 65 and 77 degrees. So the law of sines says the sine of angle A over A equals sine of angle B over B equals the sine of angle C over C. Now clearly I'm not going to use all of that all at once, so I'm going to plug in what parts I need and leave myself one missing variable. Because I have my pairs with side C and angle C, I'm going to use that one down here on the end. Sine 77 over side C, which is 65. If I want to solve for a, then I just pull this ratio here for a. The sine of a, which I know is, angle A is 42, so I can find that sine, over side A, which I don't know. Okay, erase that mistake. Okay, so I can use this ratio here. Remember how you solve this proportion? Remember, proportion is two ratios equal to each other. So if I solve this proportion, I can use cross multiplication. My note for you here is that when you have a lot of numbers that you're going to have to round, for example, if I take my calculator and I type in the sine of 42, I get a very long decimal. So instead of rounding that decimal, I'm just going to use it in my calculator. In other words, I'm going to write this all out where I can just either do it in one step or in two short steps in my calculator without having to round. So instead I'm going to write this as 65 sine 42, that's my multiplication here, equals a times the sine of 77. And then I'm going to divide by sine 77 so that it's gone from the right side. So side A equals all of this that I have right here. And I can plug all of that into my calculator all at once. 65 sine 42, be sure you close the parentheses. So in my calculator, 65 sine 42, it automatically puts parentheses before the 4. I need to make sure I close them after the 2. Divided by sine, again, my calculator gives me parentheses, so after I plug in my 77, I want to close my parentheses. And then I hit enter, and my calculator tells me that A equals 44.637. So just like we talked about before, I can round that. I don't need to write that whole decimal for my side length A. So I'm going to write it as 44.6. Again, if your teacher's okay with one decimal place, then 0.6 is fine. If they would rather have 2, then write that 0.64. Okay? If they want 3.63, and actually we would round that 7 up to an 8 because the next number is 5. So just use your calculator and what you know about your teacher to solve that. So now I have side A. So I go back to my triangle and I look at what I have. I have side length A now, 44.6. So if I look at my triangle, the only thing left to find is side B. However, I can't find that using what I have here, again, it's not a right triangle. I can't use Pythagorean theorem. I can't use sine, cosine, or tangent. So I have to go back and use my ratios again. This time, I'm going to use my ratio with B. So sine of 61 over B. And again, I'm going to make another note for you here. While we know A, because I just did it, I could do sine 42 over that value I have for A, 44.6. But again, I rounded 44.6. So instead of using a rounded value, like that 44.6, I would instead want to use a number that I know is exact. So again, I'm going to go back to C because I know that these numbers are exact. And I'm going to use sine 77 over 65 again. And then I'm going to do the same thing I just did, but I'm going to use this ratio now. 65 sine 61 equals B sine 77. I divide, so 65 sine 61 divided by sine 77. And now I can put that again all in my calculator all at once. So 65 sine 61, close my parentheses, divided by sine 77, and I get B is 58.345. So once again, I would just round that to 58.3. Okay. And then I just double check, have I gotten everything I need between the givens that I have to start with and the 3 that I've solved for? I should have all 6 parts of the triangle. I do. Those are the 3 parts that I was missing, so those are the 3 that my teacher is going to be looking for to grade. Stick those in a box and I'm good to go. Okay? So that is how we solve a triangle using the law of sines.